Hello students, and welcome to this lesson on exponential regression. Our objective today is that we will apply exponential function regressions to build appropriate models using our journal notes and practice problems. The most important key that you're going to use today is going to be your stat key. So make sure that you know where that is on your calculator. You're going to need a TI-84 calculator, or if you're familiar with Desmos, you can do this entire process in Desmos as well. So let's say that we're given a table of values here, and I want to find a regression of this data. So I want to find a function. What this means is find a function which will model the data. So, for instance, these are temperatures, right? So we're going to have one more piece of information here, and we're going to say that room temperature in this room is going to be 68 degrees. And that's going to be important for our values here. So we're trying to find an exponential model to see, this is like a cup of liquid and it's cooling over time. So these are time values that have passed, and then this is temperature in Fahrenheit. So I want to find an exponential model which will tell me what these values should be at any given time. So what I'm going to do is I'm going to press my stat key, and I want to put these x and y values into L1 and L2. So that means I need to go from stat to edit, and then I'm going to edit L1, L2. All right, so I'm editing L1 and L2, and so I'm plugging all my x values into L1, I'm plugging my y values into L2. And I'm going to want to do one more thing. So in L3, I want to go up until I've highlighted L3, and I want to plug in, I want to press second L2 minus 68 degrees. So what that's going to do is kind of normalize my data. So my data is very nice, but the thing is that my exponential regression model will only ever give me something that looks like this. So my exponential regression model can't really handle an asymptote. So what we're doing here is we are taking our data and we're bringing it to the asymptote y equals 0. So we're going from the asymptote y equals 68, and we're going all the way down to y equals 0. And that's what I've done here with L3. So my exponential regression will be, I press exponential regression, which is under the calc key in stat. So I say xreg, and what I want to do is I want to go down, and in my y list, I want to change it from L2 to L3. And that'll give me a little bit better of a data set here. So I use L1 and L3, and I get that my function here will be, it has a starting value of 135.93. It has a decay factor here of 0.955 to the x, and then I want to say plus 68 here at the end. And I'm doing that because my function that I started with has to be shifted back up to where its asymptote should be. All right, so let's go ahead and take a look at a practice problem. So a bread recipe says to bake the bread until the center is 180 degrees Fahrenheit, then to let the bread cool to 120 degrees Fahrenheit. The baker wants to know how much time this will take on average. So given that the room temperature is 70 degrees, what is an exponential model for this data set? So again, what I want to do is I want to plug this into L1, I want to plug this into L2, and then from here, I want to make L3 equal L2 minus 70. So then I press my stat key, and I go down to exponential regression. And again, I can probably leave it as is now because I used it in my first example with L1 and L3, and I can calculate. And so what I'll get is that y is equal to 127.27 times 0.836 plus 70. So remember, now we want to make sure that we're doing this plus 70 at the end because that is going to be our asymptote. And then we want to know when the bread will reach the desired temperature. Well, that's just a matter of now plugging in our numbers. So we can say y is equal to, we want to know when the bread is at the temperature 120 degrees. So now I can take my exponential regression, my function here, and put that into y equals, and then put in my second function, so this is y2, this will be y1, and I can find the intersection of those two things using my graphing calculator, and that will give me the point at which our functions will be equal. So y equals 120, and you find the intersection with our actual function. So we find the intersection point here, and it turns out that after 5 minutes, or 5.21 minutes will be my intersection. So 5.21, and we're actually going to round that to 5.26 minutes. And that's where my bread will be 120 degrees. All right, so make sure that you watch the actual videos over how to do this in your TI-84 calculator. I'll run through both of these problems in the actual TI-84 in a separate video. However, once you're done with those, write your reflection. What role does an asymptote play in a real-world exponential model? Then go ahead and start working on your assignment, 7-22, Exponential Transformations, Part 2. If you have any questions, let me know. Have a wonderful day.